Hello everyone, in the last module we covered the flying follower AI and we also covered the patrolling and aggressive AI. So in this one we are going to add shooting to both of them, and to see what that looks like, here we have our follower AI. We hold shift and we snap our rotation and then we start shooting, and then if we get to a point where the AI can see us, it'll check if it can properly see us, and if its rotation is lined up properly, then it will start shooting at us. So if I wait here and then we start shooting at it, and you see those projectiles do work and they destroy on each other. So let's get into how to implement this. So drag that off to the other screen here, and we will open up the tutorial series project. So the first thing we're going to want to do is go into our blueprints folder. We're going to create a new one, and it's going to be called projectiles. And we're going to make the base projectile class. So we're going to call it BP_base projectile. And we're going to want a few things here. So let me get the all the dimensions right. So we want a cylinder, and we're going to rotate this 90 degrees forward on the pitch, and then we are also going to set its scale down to, if I bring this down to 0.625, that's what we're going to set it to. So 0.625 on both the X and the Y. Hold on here. There we go. And then on the Z, we're going to do, let's say, 0.4. And we're going to have to undo here and then make sure that we uncheck this little lock so that works. And we get a nice little thing. And then we're going to want to set its collision to no collision. So there's quite a few tutorials out there using overlaps as projectiles. But I've noticed with this project this small, it's not going to be really a problem. But once you start having like tons of actors or something that are all shooting projectiles, and you've got like hundreds and hundreds upon hundreds on the screen, overlaps with physics, they do tend to slow down the game of it, and you will notice a hit in your performance. So I prefer to use a trace system instead. So that's another reason why I wanted to do this tutorial, and just show you guys what I do. But to each their own, you can do the test yourselves and see, what works best for you. So we're going to want to find our materials here. We're going to show in folder. So it's in third person BP folder. So materials. And then on our main, so this is the M, these are the material instances. We're going to want to make two new instances. One's going to be called MI green emissive. And then we're also going to have another one called MI yellow emissive. So on the yellow, as you guessed, it's going to be yellow. And on the green, it's going to be green. Save both of those. And then for the back in the base projectile, we're just going to put the yellow as the base one. And we're also going to want to add a projectile movement component. Alright, so in its construction script now, for this, we want to get actor location, and we're going to promote this to a variable, which is going to be called previous location. And we're going to use this for the trace here. So previous location. And we're also going to do a few other things while we're here. So we're going to do set lifespan, and we're going to promote this to a variable. Oops, not a local variable. We want a regular variable here. And we're going to call this one lifespan. And then we are going to want to drag our projectile movement into the graph here. And we're going to set initial speed. We're also going to set max speed. And lastly, we're going to set gravity scale. And just connect all these up here. straighten them out. Perfect. So initial speed we're going to promote to variable, and we're just going to drag this one straight into max speed as well. And then projectile gravity scale we're also going to promote to variable. And lastly, what we want to do is we want to get the cylinder and we want to set material. And we're going to promote this to a variable. So the reason we're creating so many variables, and we'll create a few more in a bit actually, is because when we spawn these in the world, we want to, depending on which actor is shooting it, we want to be able to change some of these things. Like for example, the material is changing the color. Maybe the enemies, we want them to shoot a little slower than the regular ones. Lifespan, it's always good to have, so you don't gotta, do some function or something like that to change it. And what we're essentially doing is creating a very solid baseline for any future projectiles you want to add in the future. Because you can always, if we go to blueprints projectiles, you can always create a child blueprint class and change some of these things and change some of the interactions that it has with everything in the world. So we're just going to delete this child for now. And we're going to name some of these. So this new var 0 is going to be speed, as it's plugged into the speed. And then this one's going to be gravity. The material here is going to be called material. And for now, all of these, except for the previous location, we want to set instance editable and expose on spawn. And we'll cover that in a second once we actually spawn one of these in the world and implement that, so you can see what that does. But that's all we need for the construction script. Now let's head over to the event graph. So we don't need tick and we don't need overlap. And just like we've done with most of the other projects, we're going to set timer by event. And this is going to be a custom event that's going to be called tick. We're going to promote to variable. And we're also going to promote time to variable. So this is going to be trace tick rate, and this is going to be trace timer. Set looping to true, and then we will start setting some of these values. So tick rate will be 0.1, lifespan will be 3 seconds, speed we'll set it to 4,000 for the base, 4,000. Gravity will do 0.1. Material will be the yellow emissive. And the tick rate is 0.1. Perfect. So, as you remember, the first thing we did was we set the previous location variable to get actor location. So it's its current location once it spawns. So we're going to do a sphere trace for objects. We want the 4 objects one. And the start place is going to be the previous location. And the ending is going to be a little bit vector math here. So we're going to get actor location. And you can just plug this in directly if you want, but since the way we're setting this up, it's going to be using the previous location. So say, for example, we were to trace from the projectile which is going out and it would hit the world, it would actually go past it a bit because there's that 0.1 second we're waiting for the timer to actually see, and you can notice some stuff. So we want it to not only check its previous location when we store it, but we also want to see where it's going in the future. And this will give you much similar to how things are with overlaps. It'll recreate some of that behavior and hide the illusion that we're using traces instead of ticks here. And you can use event tick, but having it called every single frame is also going to really hinder your performance. So I really recommend using timers for pretty much everything instead of tick. The only reason I would use tick would be to do something that with the player's camera, or something that is very important for it to be smooth on the player's side. Everything else in the world can be timer based. And for example, one thing I would change going back on previous tutorials is the rotations, for example, of these things. Since we update the velocity, the systems in Unreal Engine handles smoothing the location, but you can see a little bit of snapping as everything's turning, and if you wanted to, I would move that to tick. But also at the same time, if we're going to use tick, I really recommend you look into just implementing the tick functions alone. If you're not going to do any C++, I would do the tick functions alone in C++. Alright, so back into it, we are dragging out from object types, and we're setting world static, world dynamic, and pawn. And then we're going to do this math here for the end location. So we're going to add the current location plus a vector, plug that into end, and then we're going to get actor forward vector. And we're going to multiply this by a float. And just plug that on in. Clean this up a little bit while we're here. Next, we want to drag in the projectile movement again. We want to get velocity, and we want to get the vector length of this. So we'll do length and go down to vector length. And then we're going to multiply this by another float. So times float. And what we want to do is we want to multiply it by the tick rate here. So that way it's not getting the full velocity. And it's only getting that subportion between where it is right now and where it will be when during the next time we check this. And then we're actually going to get half that, just so the trace isn't too long. You can set that to 1 if you want, and it will check essentially the next location before we get there, but 0.5 is a nice balance in between. So that's all done there, and then we want to promote the radius to a variable, and we're just going to call this radius. Set it as well to instance editable and expose on spawn, and actors to ignore we're also going to promote to a variable, and this one we're going to set instance editable and expose on spawn, and we're going to say ignored actors. Lastly here we're just going to do a little branch. So if it did hit something, it'll return true, and if it did hit something, then we are going to break off the hit, and we're going to take, where is it, hit actor, we're going to apply damage. This is using a built-in function in Unreal to handle damage. It's a built-in interface, similar to the interface we created, but this one handles a lot of damage functions. We're going to promote base damage to a variable. We're going to set it to damage, damage, instance editable and expose on spawn, just like everything else, and then lastly destroy on destroy actor. And then off of false, so if we did not hit anything, then we want to update this previous location. So let me drag it in and set it, and we're just going to take the current actor's location and just plug that right on in, and that's all set. So that's just because it was a float before, so there we go. So this looks all set. We might want to set some of these variables. So radius we'll set to 2, or we'll even do 4 actually. Trace tick rate is set to 0.1. It is set to looping, that's good. Damage we'll just do 25, some arbitrary number for now. And then we need to actually implement the shooting part of everything here. So let's go into our interface again, flying follower talk, and we are going to have a new command called shoot, or update shooting. And we're going to have a boolean that says start shooting with a question mark, so it's clear what we're asking it. And the interface, I had someone mention to me that they weren't too clear on what interface this is after watching my tutorials. So the interface is a way that we can circumvent casting. So think about it like if you wanted to call a function on a certain actor, you would have to cast to that actor to be able to understand, like, be able to call that function before Unreal Engine would let you even say, okay, I know that this type of actor has this function, so we can call it. So what an interface does is it allows you to just completely bypass casting. You can just have a plain actor, plain object, whatever it is, and you can just send off that function message. If the actor that's receiving it has that function or has that interface, it will execute the code attached to that function. So if we call update shooting and we send it to, for example, this cube right here, since it doesn't have this interface built into it, it won't do anything. But since this actor has the interface, we actually can. So if we edit follower, for example, this is the blue guy, edit follower. Now you'll see that we do have this interface message, and we can just right click, implement function. And for example, some of them, like command follower, we actually never got around to implementing, which we probably will in another future one. If I were to just delete it and it were to receive that interface message, it still wouldn't do anything, because we haven't even since I deleted it, it won't return any errors, it won't do anything like that. Alright, so off of start shooting, I'm going to have a branch here. And maybe I should implement this from the other side first, from the actor that we're going to call it from. So I'm going to get the player, and I'm going to edit the third person character here. So I'm going to say, we need the input actually first. So following near automata, which is kind of what the inspiration was for the shooting in this game, we're just going to have a new event called shoot, and it's going to be shift. Left shift. So we'll close that out, and then now we can say shoot. So the first thing we're going to do here is we're going to set use controller rotation yaw. Set use controller rotation yaw. We're going to copy paste that. We're going to drag one into each. So on true, what we want to do is we want the player to, so without anything else, I'm just going to push play, and you'll see like I can run around in the circle here, and then as soon as I, say for example I'm running to the side, as soon as I push shift, he'll snap into that position, since we want to shoot the way we're looking. And then we're going to take our followers, since they all register themselves with us, we're going to just do a for each loop. And then we can send off that message, shoot, update shooting. So if we're pressing down the button, we want to start shooting, and then copy paste this down here. And if we're releasing the button, then we want to stop shooting. And we'll just straighten that out. So in our follower now, so for starting shooting, we got the message from the player, he pushed down the button. Then what we're going to do is we're going to set a new timer. And this is going to be, we're going to promote this to its own tick rate. And we're going to call this shoot tick rate. We'll set it to instance editable, and we'll also throw it in a its own category, so we'll call this shooting category. Have a custom event down here, and we'll call this shoot tick. Promote this to a variable, and we'll call this shoot timer. So very simply, all we're going to do, so we already have this arrow, so what we want to do is we want to grab that arrow, and we want to get world transform. We're going to split this struct, and we're also going to spawn actor from class. And here's the magic. So I don't know if you guys remember, but we set a whole bunch of variables to be exposed on spawn. So as soon as I put base projectile, you'll see that the entire node changes, and now we can see the default for every single thing that we send. So I'm going to split the struct here for the transform, since we want to keep the scale, and we don't know if the arrow's scale has been changed at all. We don't want to worry about that. We just want to make sure the projectile is always spawned at a proper scale. And so we're just going to use the defaults for the players, and then we'll change some of these for the enemies. So off of ignored actors, that's the only thing we need to do, is we need to first put self, and then we need to also get the reference to the player. And what this will do is make it so that when we're tracing, the trace will not hit either the actor or the player. So the little follower or the player. If you have more followers, you might want to have it so they don't collide with each other. since the system is set up that you can just drop 2 followers in a world and they'll both follow you, no problems. You might want to have a way to cross-reference them. You can always, for example, off begin play, you'd be able to put a little delay after this add follower, and then get followers, and you could save that to an array, and then you can just plug that array directly into ignored actors. So we got to make sure we set looping to true. We got to make sure we set the tick rate. For this guy, we'll set 0.1. It's a good number. And lastly, if we're stopping shooting, we need to stop this timer. So we'll get the shoot timer here, drag it into its shooting category, and we're just going to clear and invalidate timer by handle. And actually, one last thing I want to do while we're here, so we don't got to come back again, we're going to update this rinterp speed. So it rotates with the player a lot faster. So that is from movement, I believe. So we're going to set rinterp speed. And then if we're starting shooting, we want to set it to 20. If we're stopping shooting, it is currently 2, so we'll set it back to 2. And while we're here, also I forgot we need to change the flying player query here. Instead of using the rotation for the arrow, we can just use the rotation for the camera. So that way when we look up and down, the rotation of the follower will look up and down with us. Alright, so let's give this a shot. So our player's shooting properly. Collisions are set up so it doesn't hit us. And now we can look at this and start shooting it. And actually, one other thing I want to do while we're here is I'm going to click on the camera boom. We're going to raise this up to eye level for the player. And we're also going to offset it just a touch. So we'll do 50 on the Y. And there you go. Now you get more of like an over-the-shoulder kind of shooter vibe with it. Now you can aim a little better. Alright. Now let's go into the aggro pawn. So we have aggro, and we're just going to edit this blueprint here. And we're going to add a new timer. Set timer by event. We'll do a custom event. And we'll call this shoot. Or check to shoot. Or shoot tick. And then we'll create another event up here called check to shoot. Set looping to true, promote it to a variable, promote the timer to a variable, just like we've been doing. And then on shoot tick, we're going to call check to shoot. So that way we can clean up this space a little. And we don't run into this trap where we create a bunch of code depending on how long it's going to be for you guys. Alright, so we want to steal this flying mode check. So we want to make sure that the flying AI is in aggro mode and it's not patrolling. And we're actually also going to steal all of this right here, where we get player character and we get the actor's location, we get the player's location, we get the vector to it, and we get the normalized vector. And we're going to want this dot too. So we'll get all this, we'll get the dot, and then we'll get the greater than. So for this one we use 0.5. I'm going to come down here and we're going to use 0.9 for this one. So it's got to be looking pretty much directly at the player for this to work. So we're going to call this shoot dot. Compile that, set it to 0.9, and this is the shoot tick rate. This is the shoot timer. We'll throw that all in its own category, shooting. So we're going to do branch here. So if we're in aggro mode and we're looking pretty much directly at the player, then we're just going to spawn actor for class. we're going to set the base projectile. And similarly, we're going to take the arrow, we're going to get transform, get world transform, split both of these just like we did with the original one, plug that on in, plug the rotation in too, set. Okay, so this is where we change some things. So actors to ignore, just like the last one, we're not going to ignore the player here since we want to hit the player, so we're just going to do self. The radius, if you want to make it a little easier to dodge, you can do like 2 for example. Gravity will leave the same. Speed will half it, so it'll be 2000. Lifespan will leave the same. Damage, you can do like 5, 10, whatever you wanted. And we want to change the material to the green emissive this time. So now, we push play. We get in the range of this guy. Let's see, why is that not working? We said it's looping to true. Let's get rid of the trace visibility. So we'll trace debug to false. And let's do some debugging here. So I'm just going to do a print string, and we're going to check this dot right here. Shoot dot, that's 0.9, perfect. So let's see here. Oh, it's not even calling the function, huh? Shoot tick rate. Oh, it needs to be a variable. So this is going to be how fast it shoots. So we'll do 0.2. Our guys is 0.1. This guy will be 0.2. So we can shoot twice as fast. Our projectiles move twice as fast. And there we go. That's working now. And you can directly check how fast you're shooting. See if he's like really like, he's got like wall hacks almost, and he's like super quick with it. You could lower his interp speed, and he would rotate just a bit slower. So I think we do have that. There's an aggro interp speed. We'll lower this to like 30, for example. What's patrol? 5, yeah. So let's see how fast this guy shoots now. So can we outrun? Oh, he's still catching up with us. Alright, we'll lower this down to 7. He's really catching up on us. Alright, let's do 5, and then patrol interp will do 4. We are getting much lower on the dot. We got down to 0.91. Does look like it's still a little too fast, but it should be fine. Can easily outrun the projectiles even right up here. There you go. Just run past him and he can't even shoot you. So we got the shooting done. He's shooting at us. Our projectiles, if we shoot him really quickly and then look behind, you can see that they are getting destroyed. There's no health system yet. I think we're going to do that in the next module as we do the health system as well. And you can also see that his projectiles are hitting us. And you see how it's clipping just slightly through us? That is because we're only doing the 0.5 when it comes to the checking for the distance. So you would be able to mask that a bit with a particle, like for a particle destruction particle or something like that would be a really great way to mask some of the visual glitches you see when using traces as projectiles. Alright, so I think that's going to wrap up this module. It's almost a nice 30 minutes. Just a reminder, slap like, subscribe, and there's a Discord down below if you wanted to join and ask some questions or ask for some help. I'm always here. I'm always willing to help out people, so please feel free to join, and thank you for watching. Have a good one.